Okay, so on Wednesday's quiz, we're going to be looking at 3 topics: domain and range, how to read a graph, and the library of functions. So let's start with domain and range. Domain and range, you're going to need to know how to recognize the domain of a function just from the equation, and then you're going to need to be able to look at a graph and tell me what its domain and range are just from looking at that graph. In order to read a graph, we need to know how to find the maxes, the mins, where's the graph increasing, and where's the graph decreasing, and if any intervals, where is it constant. And like we already said, we are going to need to know what the domain and range of that graph are. And lastly, we're going to look at the library of functions. So all 6 of those functions that we studied, how can they be transformed, how can I write their equations, and how can I identify each one of them. And that pretty much takes care of it. So now we'll go through a brief review of each individual topic. Okay, so there's 3 scenarios we need to consider when we look at domain of a function: polynomials, rational functions, which we refer to as fractions, and radicals, namely the square root function. So let's look at polynomials first. Any polynomial that you come upon will always have a domain of all real numbers. And that's because there's never a restriction placed on what you can put into those types of expressions. So if you see something that looks like a polynomial, chances are the domain is all reals because there is no problem with any of the numbers we could put in. So that's an easy case. Now, the 2 more important cases. First, let's look at rational functions. Let's suppose you had a function like f of x equals 2x plus 1 over x squared plus 3x minus 4. In this case, our biggest concern is, since it's a fraction, there's one restriction, and that is the denominator can never be 0. So we have to set that denominator equal to 0 and find out what are the problems, what are the numbers, the values of x that we can't use. So in doing this particular one, we're going to have to factor. So we factor into x plus 4, x minus 1, and we solve each piece of that. And what we find out is x can't be negative 4, and x can't be 1. Those are the 2 numbers we can't have. So what we have to do now is express that in the various intervals. Where are the intervals of numbers that we can have? So negative infinity up until negative 4, but not including negative 4. Anything between negative 4 and 1 would be okay. And then from 1 to infinity. And there's your domain for that rational function. So anytime you're dealing with a fraction, you're going to want to think to yourself, where is that denominator equal to 0? Now let's do the last case. Radicals. What happens if we're dealing with something like f of x equals the square root of 5 minus 2x? Now, unlike fractions, there is no denominator here, so we can take the square root of 0. That's not a problem. That's okay. The one issue we have with square roots, though, is where will they be negative? Because we can't take the square root of negative numbers. So the best bet here is to take whatever's underneath the radical, set it greater than or equal to 0, and solve that short inequality. Now when we do that, just be careful, don't make any silly mistakes. Make sure you have to flip the sign here because we're dividing by a negative. You're going to wind up with x is less than or equal to 5 over 2, which means we can use any number less than or equal to 5 over 2. So how do we write that in an interval? Well, negative infinity up until 5 over 2. The only difference here, maybe from the last problem, is we can include 5 over 2. So we're going to use a bracket here, and that'll cap off our domain. And that takes care of it for domain and range. Now, the only other thing we have to do is learn how to express the domain and the range when we're looking at a graph. And I'll take care of that in the next segment when we look at reading a graph. Okay, take a look at this graph. We have a lot of things going on in this graph, and one of the things we're going to try and take care of here is how do we express the domain and the range? How do we identify the maximum and the minimum points? And then how do we express where this graph is increasing and decreasing? So let's take a look at that. Okay, let's start with domain. Now when we look at a graph, the domain of that graph is basically where the graph starts along the x-axis and where it ends. Now in this particular instance, it looks like it starts right here at negative 3. And it looks like, because of this arrow right here, that it goes on forever. So in order to express the domain, we would just say it starts at -3 with a bracket, and it goes on forever to infinity. Now for the range, what we're looking at here is what's the lowest value that this graph attains, and what's the highest value. Now remember this arrow, okay? This arrow indicates that the graph's going down forever. So the lowest value it would ever get to would be -infinity. So we would say -infinity, right? And then it looks like the highest value is maybe just a little bit above 8 over here. So maybe we'll say that that's, let's say 10. I'll make sure that on the quiz it's very accurate. But for now, we'll just say about -infinity to 10. So that takes care of domain and range. Let's look and see if there's any maxes or mins. A maximum point, you have to be able to see the graph go up and then down. And we see that here twice. We see it right there, and we see it right there. So one of the maximums, I would say it's -2, 8. And I would say the other one is maybe 4, 10. Now, the minimum point, you'd have to be able to see it go down and then up. So we have a minimum right here at 1, -4. Now these are important values because they also tell us where the graph starts increasing, stops increasing. Starts decreasing, stops decreasing. And so we're going to now try and classify those intervals. Now remember, we're going to use x values in interval notation here as well. We're not going to use y values. So it looks like right now we start increasing right there. So I would say that we're going to increase from -3 to -2. See, during this time period right here, the graph's going up. So -3 to -2. Then it happens again from, it looks like maybe 1 to 4. See, during that whole time period, the graph is going up, right? So 1 to 4. Now, where is it decreasing? Looks like from -2 to about 1. And then again from 4 to infinity, really. You could say 6, but the graph goes beyond 6 because of that arrow, right? So we'll say 4 to infinity. Now watch out for arrows on this side too. We don't have them in this graph, but in some graphs you would see that. And so that would mean that, let's say for instance, the domain would start at -infinity. That first interval of increasing would be at -infinity, so just watch out for those things. And so that's really all we're going to need to know in terms of how to read a graph. And the last piece of the puzzle here is those 6 library of functions that we talked about and their transformations, so we'll tackle that next. Now in order to graph y equals the negative absolute value of x plus 1 plus 4, we need to know what these 3 things are doing. This negative sign is important, the plus 1 is important, and the plus 4 is important. So the negative sign outside of a function indicates that that function is going to flip upside down. So ordinarily, the absolute value graph would look like a standard V. That's what its parent graph would look like. This one's going to have to flip upside down. This plus 1 inside grouping symbols means that there's going to be some type of side-to-side shift. Since it's a plus 1, we actually are going to go to the left. So we're going to go left 1. And this outside number indicates an up and down slide. So this plus 4 means we're going to go up 4. So the last thing we need to do is incorporate those 3 characteristics into our graph. So we start with the parent graph, the absolute value, right? We're going to be shifting that 1 unit to the left, 4 units up. And so the new graph needs to be right there. However, it needs to turn upside down, right? So that pivot point would really be at -1 and 4. And there's your finished product. Okay, now let's finish up by looking at this equation this graph down here and writing the equation. The first thing we need to notice about this graph is what kind of graph it is. This is an adaptation of the square root graph. Remember, the square root graph would ordinarily look like that, but it's obviously been turned in a different direction. So what makes that happen? Well, when it turns itself kind of like a book and faces the other direction, left or right, that means there was a negative placed inside the symbol. So where you would ordinarily have the square root of x, this is going to be the square root of -x. Now, it's also been moved, right? Ordinarily, this would anchor itself right at 0, 0. But it looks like it was moved 1 unit to the right, and it also was moved 2 units down. So like in the last example, just we're going backwards now, that side-to-side shift is indicated inside the symbols. So since we went to the right one, that actually would indicate -1 in our equation. And And since we went down 2, we would stick that -2 at the very end. And that's it. So make sure you study. Make sure you do some of this stuff without your calculator. If you have any questions, just email me or come on in and get a little extra help. Okay, I hope this was helpful.